Hello everyone, in this video we're going to be learning lesson 1.7, functions as rules and tables. So you've probably heard of the word function before, and that it could be represented as a rule, a table, like a rule is an equation, tables, and in the next lesson we're going to be learning about graphs. And also we're going to talk about the difference between a relation and a function and determine if a relation is a function or not. There is a certain criteria that makes a relation a function. And if you think about it, everything in life is related. For example, what you wear to school every day depends on maybe if you have gym that day, or how cold it is outside, or maybe how cold it is in your teacher's classroom. What you eat for lunch might depend on what you're doing after school. Just everything that you do is related to something else. So what is a function? Well, here are 3 different ways we can represent functions. The first one on the left is in like an input-output like generator. So you input something into the rule and it plugs it into the rule, and then you get an output. Also in an XY table, so the inputs are -2, -1, 0, 1, and 2, and your outputs are -3, 1, -1, 1, 3, and 5. So each input goes to an output. And you can also represent it by this chart here on the right. So all of the numbers in the input, which also represent the domain. So the domain is the same thing as x, and the range is the same thing as y. You're probably familiar with these terms, so this is going to be a little bit of review. Now, the criteria in order to be a rule is that every x can only go to one y. So the x's can't repeat. X's can't repeat. But the y's can. Y's can repeat. So for example, in this last one, none of the x's repeat. So it's just -1, 0, 1, and 2. They only happen once. However, the 4 does repeat because it's an output from -2 and 2. So that's allowed to happen. Okay, there's also what's called a vertical line test, and we'll talk about that in the next lesson because that's related to graphs. So some other vocabulary. The domain consists of all the numbers called inputs. Sorry, my handwriting is a little sloppy. And that is also the x. And we know that on an xy axis, that represents the horizontal component. And now for the range, contains the numbers called the outputs, which is the y variable, and it's the vertical component. So a pairing of inputs and outputs having an ordered pair such that each input is paired with exactly one output. That is what a function is. So functions such as x equals 1y. So each x only goes to one y. And that's related to a video that you'll see on Monday in class. So here's a couple examples. Identify the domain and range of the function. So the domain is just all of the inputs. So here, this relation is on gallons and dollars. So the number of gallons you buy, well, the amount that you pay will depend on the number of gallons you you buy. So the output is also what we call, sorry about that. We also call the output the dependent variable. And the input we call the independent variable. Because the number of dollars you spend depends on the amount of gallons you buy. So the domain is just all of the x's, all of the numbers in the input. So 10, 12, 13, and 17. And then the range is all of the outputs. So 19.99, 23.99, 25.99, and $33.98. So you could just write them in a list like that. Is there another example down here? Nope, that was it. All right, so a mapping diagram. So this is what we call a mapping diagram that you saw on the first slide. Function may be represented by a mapping diagram. Notice that an output may be paired with more than one input. For example, 2 is paired with 3 and 4, but no inputs are paired with more than one output. So 1, 2, 3, and 4, you don't see any of these numbers in the inputs repeated. So here's an example of a mapping diagram. Tell whether the pair is a function. So part A, would that be a function? The answer is no, because 0 repeats. For example, if you were to write these in an ordered pair, it'd be 0, 2 and 0, 3. Do you see how 0 repeats in both the x's? So 0 can't go to 2 and 3. It can only go to one of them if it's a function. What about part B? This would be yes. Each number in the input is not repeated, only goes to one output number. Number 2. Well, technically the third part to this example. So look at the numbers in the input. Do any of them repeat? So would it be a function or not? This answer is yes. So even though you see the numbers in the output repeat, as long as the numbers in the input don't repeat, then you're okay. In the next example, this would be no, because 2 and 2, those repeat, they go to 2 different outputs, and we can't have that to be a function. So 2 repeats. So let's talk about function rules. So writing a rule for a function may be represented using a rule that relates one variable to the other. By variable, I'm just talking about x and y. Also to note that f of x, we're going to be using f of x, so you've probably seen that before, is the same thing as y. So notice I'm not saying f parentheses x, I'm saying f of x. F stands for function. So a function of x, a function whose independent variable is x. So the independent variable is called the input variable is called the independent variable. And you can think of that because input, independent. Input, independent. This is your x. And then the output variable is called your dependent variable. And then the independent variable always goes on the x-axis, and the dependent variable always goes on the y-axis. Because its value depends on the value of the input variable. So y depends on x. So here's a little table. So the verbal rule, the output is 3 more than the input. So if the output is the output is y, the input is x. So the output y means equals 3 more than an input, so 3 plus x. But we always write the x first, so it's going to be x plus 3. And then here's a table to represent that. You can also say f of x equals x plus 3. So here are the given inputs. The output is just 3 more. So 1 plus 3 is 4, 2 plus 3 is 5, 6, and 7. And this is also saying, so f, you wanted to find the function when x equals 0, you could, this is just notation here. You could say f of 0 equals 0 plus 3, which is 3. So f of 0 equals 3. So when x is 0, y is 3. We could do that for all the other ones. F of 1, we would just plug in 1. This means plug in 1 for x. Plug in 1 for x. So this would be 1 plus 3, which is 4. So f of 1 equals 4. And extending the page, f of 2 would be 2 plus 3, which is 5. So f of 2 is equal to 5. Well, I'll do one more to make the point. F of 3 is 3 plus 3, which is 6. So f of 3, the function when x is 3, is 6. So when the input is 3, the input is 3, the output is 6. So that's just important notation to get used to. So let's do a few examples here. Make a table for the function. So when x is 0, 2, 5, 7, and 8, and your function is 2x, well, the rule is just multiply x by 2. So 0 times 2 is still 0, 2 times 2 is 4, 5 times 2 is 10, 7 times 2 is 14, and 8 times 2 is 16. So we're just doubling the input, which means all of the outputs are going to be even. Okay, write a rule for the function. All right, so notice that the input goes 0, 1, 4, 6, and 8. The output's 2, 3, 6, 8, and 12. So notice what's happening between each input and output pair. So are we adding? The first thing is to see if you're adding or subtracting something each time. If not, you can see, okay, are you multiplying or dividing by something each time? So in this case, we're actually adding something to each x. We're adding 2. So notice it's plus 2, plus 2. 1 plus 2 is 3. 10 plus 2 is 12. So the rule would be y is equal to, or f of x is equal to, x plus 2. Number 5, you're buying concert tickets that cost $15 each. You could buy up to 6 tickets. Write the amount in dollars you spend as a function of the number of tickets you buy. So first of all, it's good to note the independent variable. Independent. There will be questions on this, like which variable is independent, which is your x, and the dependent variable, which is the y. So whatever the dependent variable is, it's going to depend on the other variable. So we have number of tickets and the total cost of the tickets. So it says write the amount you spend. So this would be the total cost that you spend of a function of the number of tickets you buy. So in this case, the amount of money you spend is the dependent variable. So total cost of tickets or money spent. usually total cost and money spent is going to be the dependent variable, whereas the number of an item you buy is going to be the independent variable. The number of tickets. All right, so to write a rule, we would say y is equal to, and then each ticket costs $15. So in that case, when something costs $15 each means to multiply. So we'll just do 15 each. The 6 is actually not relevant in finding the equation here. It's just the 15 that depends, or that's going to tell us how much money we'll spend. All right, and that is it for now. Yeah, I will put the exit ticket actually in your homework assignment. So now when you come into class on Monday, you will work on the Elastic assignment that goes with this lesson. All right, everyone, have a great weekend.